Hello everybody. Let's see the today's problem. Today's problem is on the chapter of circular motion that requires the fundamental concepts of centrifugal acceleration as well as it requires the concept of Newton's law of motion and free body diagram. Let's see what this problem tells. A small block slides down from the top of a hemisphere of radius r. At what height h above the ground, the block will lose the contact with the hemisphere surface. Let's try to analyze this problem. What will happen? This block will slide down like this and there is no friction is there. So let's assume at this point the block will get some velocity v. So at this point the block will have centrifugal acceleration directly radially outward direction. The centrifugal acceleration will act outward. So what is the centrifugal force acting on the body? M into v square by r amount. Now how to calculate this velocity v? How much height it is covering while sliding from top to alpha, this angle. Let's assume at this angle alpha, it is losing the contact with the surface. How much height it is covered? This is, say, this is r, the radius is r. And what is this height? R cos alpha. So how much height will be this one? This is entire thing is r, this is r cos alpha. So it will cover height r minus r cos alpha. So what is the expression of velocity if it covers h distance from top? Just due to the acceleration of gravity, the velocity will become 2g into delta h, height covered in vertical direction. That will be 2g into r into 1 minus cos alpha. That is pretty much straightforward. So what will be the amount of centrifugal acceleration will be acting on the body radially outward? mv square by r amount. Right now we are assuming the mass of the body to be m1. So what is this acceleration? And the force? V square if we do, we will get 2gr 1 minus cos alpha. So here this r will be same, capital R. This r will be cancelled, numerator and denominator. It will be 2mg 1 minus cos alpha. Now let us draw the free body diagram of the body when it will lose the contact with the surface. Let's say the mass is here. The angle theta. Now we'll draw a tangent at this point. Now see, this is angle theta means this is also angle theta. And what is the angle this tangent is making with the horizontal? Angle theta only. Because this plus this equal to 90 degree and this plus this also equal to 90 degree. So the tangent is making angle theta with the horizontal. So it can be assumed as a imaginary inclined plane where the block is situated. So mg is acting directly downward. Now the component of mg along this imaginary inclined plane in this direction is mg sin theta. This direction is mg cos theta. The block is getting normal reaction from the surface in radially outward, and another force is acting on the body, that is centrifugal force Fc. Right now, what is the equation of motion in the radial direction? N is acting outward radially and Fc is also acting outward radially, that is equal to mg cos theta. So here in this case, this alpha, to light alpha. So when it will lose the contact with the surface, that means the normal reaction will be zero. The centrifugal acceleration will exactly balance the radially inward component of the weight. So we can write that 2mg 1 minus cos alpha is equal to mg cos alpha. Now from this triangle, we can tell that what is the value of cos alpha? Cos alpha in this triangle h by r. So we can directly put that 2 mg 1 minus h by r is equal to mg into h by r. So mg will cut both the sides, then 2 minus 2h by r is equal to h by r. Now 3h by r equal to 2. What is the value of height? 2r by 3. That is the answer. I hope you have understood this problem. Thank you so much.